Math, the final frontier. These are the voyages of the mathematicians. Their continuing mission, to explore strange new equations, to seek out new problems and new solutions, to boldly go where no one has gone before. Welcome, mathematicians, to another exciting episode of Math Notes. Today, we will be finishing up our study of evaluating for exponential decay. Hope you guys are ready. This is going to be just like our notes from last time, where we talked about exponential growth and we evaluated, but today instead, our graphs are going to be going down to the right instead of up to the right, which means they're going to show decay. Maybe your house loses value over time. Maybe you buy a car and the moment you drive it off the lot, it loses value. For whatever reason, some things' values decay over time. A famous one is radioactive material. Famously has a half-life that decays over time. So today we're going to actually solve for some exponential decay. So what does that look like? Well, last Tuesday, if you review with me, we learned about substituting values into equations to evaluate an exponential growth equation. And we applied that knowledge to some word problems. But today, we're going to use the exact same process to evaluate exponential equations that decay. So here's the three things we look at together. The necessary information we need, what are the steps required, and what are some examples. So, very similar to last time, but what I want you to notice is that now we have subtraction, but otherwise it looks exactly the same. But if we're subtracting here, then our b value will be less than 1, which means this is going to be a decay problem. Same as last time, our y represents our final amount. A is going to represent the initial amount. How much did you pay for the picture, for the car, how much plutonium do you have that's radioactive, etc. R represents the rate of decay, T is the time, and 1 minus R we call the decay factor. So there's the necessary information. Now, Mr. Pratt, what are the steps required to solve these? Well, I'm glad you asked. They're the same as last time. You substitute some values into an equation. You then solve the equation by following the order of operations, and then identify your answer and write it out appropriately. So let's look at a couple examples. I have two up here in the vast nebulous space, but the steps I hope are pretty easy. Substitute each of these values into our equation just like we did on Tuesday. So, but because we're working with decay now, make sure you have a minus instead of a plus in your equation. So I've got 10 for A, 0.2 for R, and 4 for T. Just like last time, let's follow our order of operations by resolving the parentheses first, then the exponent, and then we're going to multiply. So you see I did 1 minus 0.2 is 0.8. 0.8 to the fourth, or to the fourth power, means multiplied by itself 4 times, gets me 4096 10,000ths. And then we multiply that by 10 and get 4.096, or approximately 4. Well, hey, that was our first decay problem. Well done, making it through. Let's look at the next one. Same exact idea. Let's substitute our values in. Pretty straightforward, and it's going to be just like this on your assignment. Now, again, working with decay, so make sure your equation has a minus sign. And we have 5 for A, 0.7 for R, and 3 for T. Let's subtract inside the parentheses, which gets us, let's see, 1 minus 0.7 is 0.3. Then cube the 0.3. Resolve the exponent by cubing the 0.3. So 0.3 cubed is 0.027. If you got a calculator, great. Any calculator will do 0.3 times 0.3 times 0.3. The simplest calculators are computer, Alexa, or you can do that, of course, by hand. Then we're going to multiply this by 5, and we get 0.135. Nice. So our answer is 0.135. Man, I feel like I'm flying through this, but the reality is, if you did your work on Tuesday, this is just the same. just decaying instead of growing. Same steps. Now, here's an example, maybe from real world. The value of a car is $18,000. Now, I've bought a car before around $18,000. Do you think car values go up as you own them or go down? Well, you would be correct if you said they go down. That word is depreciate. So car values depreciate over time. They lose their value. Nobody wants an old car if you could buy a new one, so they're cheaper. Let's see, it's depreciating at a rate of 12%, so they've given us a rate. And we want to know after 10 years, so we also have a time. First of all, since the price of the car is decreasing, we know this represents decay. So we're going to use the minus equation. Let's identify the pieces. A is 18,000. R is, 0.9. My apologies, that's a typo. You can see it should clearly be 0.12 down here. So scratch that out and write 0.12. We'll plug each of these values in, and our new equation looks like this. 18,000 times 1 minus 0.12 to the 10th. Resolve the parentheses, subtracting here, we get 0.88. Then we're going to resolve the exponent, 0.88 to the 10th. That's a lot of multiplying. Calculator would be helpful there. I've got an approximate decimal here. And last, we multiply 18,000 by 0.279, and that tells us 5,022. So your car, which you bought at 18,000, after just 10 years, is now worth only $5,022. That's kind of a bummer. But ladies and gentlemen, that's as easy as this is. The same 3 steps. Plug in the values, solve them by following PEMDAS, and at the end, make sure you write your answer out appropriately. You guys have been awesome. You only got 1 more week left. Get out there, knock out that 5-question assessment. You guys are the best students there are. If you have any questions, make sure to text your teacher through Remind or email them or call them or whatever you can do. Have a wonderful weekend, and we'll talk to you next week.